So this is the new 8K model by EG4. It's an all-in-one solar power system, so it has an inverter, solar charge controller, and AC charger in one box. Also, it's completely waterproof, including the connections on the bottom. Even the battery cable connection is waterproof, which makes it very difficult for me to put this on my desk. That's why we're doing a review out in my lab. Now check out the build quality. Look at how good this looks. This looks like a Solarc or something else that costs 3 times as much. So on the left, we have a battery connection for 48-volt battery. Next, we have the control board with lots of communication options. This thing can communicate with BMSs, or you can program it with a computer. And down here are the connections for solar panel input, generator input, grid input, and then the loads. So first on the left, the PV input is actually 4 MPPT solar charge controllers in one. You can connect a maximum of 12,000 watts to these terminals, and each terminal can handle 500 volts and a max current of 12 amps. So each input can handle its own single series string. Next, the generator connection can only handle 10 gauge wire, and that's because it doesn't have the same grid interactive features as this input. So the generator input is only for the AC charger. Now check out how large these terminals are for the grid connection. The AC charger that's built in can actually output 190 amps at 48 volts. That's 9,120 watts. If you divide that by 240 volts, that's 38 amps. So that's why these connections are so large. Next, we have the inverter output, load 1 and load 2, and these can output together a maximum of 8 kilovolt amps. So that's 1,500 watts more than an LV6548, and it's split phase capable, so we have 120 and 240 volts. So you can run EV chargers or heat pumps or whatever you wish. Now you might be wondering, why is there a load 1 and a load 2? And that's because on this inverter, it has a special feature where load 1 is for critical loads only. If you're using this inverter for off-grid use only, you're going to want to connect all your loads to load 1. Load 2 is for not critical loads, and it will shut down if there is no grid connection or if the battery is insufficient. So for most people, you're going to want to stick to load 1 and ignore load 2, in my opinion. Now this feature is automatic, or you can trigger it manually. Now we really need to talk about these terminals because they're very different and we've never seen them on the channel previously. These have to be used with solid core wire or a multi-strand wire inside of a ferrule. Now when you want to install the wire, you need to use a flathead screwdriver on this orange square, push it down pretty hard, and then insert your wire or ferrule and then release it, and then gently tug on it to make sure it's actually holding. These are very easy to use, but you cannot use multi-strand wire. Do not even try that. Also, the manual recommends different size wires for each connection. The battery connection is 2-aught gauge. The PV connection is 12 gauge, the generator connection is 10 gauge, the grid connection is 8 gauge wire, and the AC output is 10 gauge wire. Now this model is actually grid interactive, and what that means is that you can legally, because it's certified to do so, backfeed the grid. And these features make it a true hybrid inverter. You can either use it as an AC coupled system with CTs that actually come with the unit and offset your loads without backfeeding the grid, or if you have an agreement with your utility and you have net metering, or if you get credits, you can use this to take the excess generation that you produce and legally backfeed the grid. And they have to be certified to do so, and you have to pass inspection and get permits. But this can actually do that. Or you can use it strictly as an off-grid inverter, and you can use the AC input only for the AC charger, like other all-in-one systems. So you don't need to use these grid interactive features at all, but you can if you wish to do so. Now, even though this is waterproof, I was reading the manual this morning, and they do not recommend to have this unit in direct sunlight and with rain exposure. So even though it's waterproof, you want to avoid the rain as much as you can. You do not want snow to accumulate on the top of it. And that's pretty much it. You can still have it outside, but you want to protect it a little bit. I'm sure you guys want to know what the idle consumption is. On the manual, it states 115 watts average, which for this output and the amount of MPPTs that are built in, that's pretty good. But we'll test that when we hook it up. Now on the side of the unit, we have cooling fans and 2 switches. This is the main power on and off switch. Then over here is the PV disconnect. So you can turn the PV on or you can turn it off. And then there's a display with 4 buttons, but we're gonna try to program this with a computer or cell phone or something else instead with the communication connection. I cannot believe you can buy this for so cheap. This thing is like a budget off-grid Solarc, pretty much. Whew, this looks fantastic. Look at this. So the inverter output and the UPS switching functions are right here. And on the other side of this board is the inverter circuit, because that's where all the cooling is occurring. And you can see the capacitor bank, you can see larger bus bars, you can see all sorts of cool stuff down there. Over here we have the PV disconnect, and this connects to the MPPT solar charge controller. And there's 4 of them. You can see all of these leads going out to each circuit. And then on top we have the control board. I don't want to remove this to look at the inverter circuit because there's so many connection points and I really don't want to screw anything up. But everything looks great. This is like a Solarc build quality for like half the price. And this is all sealed. There's a gasket for every cover. So let's hook it up and see what it can do. This thing has no handles, man. Carriage bolts are great if you're mounting it to wood. It fits it perfectly, a 1/4 inch. This is a bit heavy. I'm gonna have to use my back to lift it. Whoa, that's a lot of weight. Oh man, it actually works, look at this. I just built it this morning, so I'm pretty happy. Now we can finally test inverters without taking down my whole system. Every time I had new inverters, I had to rebuild the system, so this is fantastic. And this thing can support 900 pounds, so we can put any inverter on here that we wish. We're actually gonna use a Torx screwdriver this time. Be a good example for all the beginners. We should check if we need to do a ground neutral bond at the output. It might not need it. So I can't find a clear answer on if I should bond it or not in the panel, and I don't want to screw anything up. I don't know if there's voltage on ground or something between ground and neutral. So we're gonna fire up this inverter, and then we're gonna see if there's continuity between ground and neutral, and then we'll do the ground neutral bond, or we might not, so we'll see. Now this inverter is massive, so we need to use a pre-charge resistor and charge up the capacitors. I have the positive connected, but once we connect the negative, there's gonna be a massive inrush. So we're gonna avoid that with a pre-charge resistor. And I've already made a beginner video if you don't know how to do that. And I can't find it. Where the heck did it go? I always lose that thing. I have like 10 of them. I can't do this unless I have that. Oh, found it. I do not like doing this. I know it's safe, but gosh, it's a lot of current that could go through this. This one's big, so I like to let it charge for about 20 seconds. Oh, we still had a spark. Gosh dang it. So you might have to charge it for like 30 seconds instead. That's a pretty big bank of capacitors. Nice. And it's on. 240 volts. Now let's test for continuity. It would be nice if they made this box a little bit bigger. This is a little cramped. There is no bond, so we're gonna create one in the panel. And that makes sense, especially if you have multiple of these in parallel. So we'll create the bond in the panel and nowhere else in the system. But first we need to turn it off, and now we can connect everything. And we're using ferrules and a ferrule crimper. We're gonna test for voltage before I start pushing things in here. All right, we're good. Actually, these are pretty safe to use. You would not touch the conductor at all once it's in there. That's nice. That is nice. I like that. Wow. Perfect. We could add a solar array, actually. Yeah, let's do that real quick. They have some nice little adapters here for your PV cables. And now the array is connected. There's no sunshine on this thing, so we're not gonna be able to charge until tomorrow. So now we have a solar array connected, a breaker box with some loads, and we have a battery connected. That's all we need to build a solar power system. So we're gonna put this cover back on and fire it up. Now realize we have 2 inverters that are not in sync that are feeding the same panel. So we're gonna keep this breaker for these inverters shut down, and then we're gonna turn this one on so we can power the loads just with this inverter, not the other system. So this one's off, this one's on, and we're gonna turn on the loads. So first we're gonna turn on the inverter, and we're also gonna turn on the solar panel array, and let's see what happens. and we have power. It's running my 240 volt heat pump. Now we're gonna start charging the Tesla and see if we can crank out 8 kilovolt amps from this unit. Need to turn down the current before it starts charging. And it's charging, oh my gosh. And I hear the cooling fans on the new inverter. Uh-oh, I think I need to change the settings because it keeps shutting down, so I'll be back in a day. So fast forward a few days later, and I'm unfortunately having an issue with this 8K inverter. Every time I connect it to an EV charger, it trips its internal GFCI. And I've tried 4 different EV chargers, and I've tried all of those chargers on the grid and with other inverters without any issues. But when it's connected to this 8K inverter, it trips the internal GFCI. Now this inverter has a display option that shows you the DC bus voltage of 240 volts, and it shows leakage current. And typically it shows 5 to 7 milliamps. And I was thinking maybe the electric vehicle charger was detecting a difference in some leakage on one leg and was pulling more current from one side than the other, and it was causing it to trip. Also, these inverters have their own GFCI. So this morning, with the help of Signature Solar, I disabled GFCI and some other options, and we're still having the same problem. So Signature Solar is setting up the exact same issue that I'm having and seeing if they can fix it on their own. But this morning, a Chinese company sent out the exact same inverter. I don't even know what company this is. So we're gonna fire this one up and see if it has the same exact issue as the Signature Solar 8K inverter. Now, if this new inverter does work without changing any of the settings and having the GFCI enabled, then that would mean that there's a quality control issue in here and there's some leakage going on in the board or something funny. Now, if the new inverter has the same exact issue as this one, then we're gonna have to go through all of the settings and figure out what's wrong because there has to be something that I'm missing. Uh-oh. This box has some shipping damage, so I hope it's okay. This one got dented right here, and it got dented right here. You'll notice that this thing's damaged. And that's pretty much it. That's actually not that bad. These heavy inverters get damaged in shipping all the time. Now, the Signature Solar one was on its own pallet, and that's the best way to get these to your house without damage. Because if you throw them in a box like this Chinese company did, the chances of damage are much higher. Oh, here we go. It's by Megarevo. I don't think I've ever heard this name before. And this is a carbon copy of that one. It looks identical. So these are absolutely created in the same factory. Even the decals are the same, the terminals, everything. I also found out if you push these ferrules into those terminals, it will click right in. Super easy. All right, we should be good to go. Oh no. And it has an error code. It states BMS communication failure, so that means we need to switch the settings to lead acid. The EG4 actually arrives out of the box with lead acid, so this one does not require BMS communication. So first, let's disable that. And then set the absorption to 58 volts. Oh, there we go. Leakage current is 9 milliamps, so it's actually more on this one. But we have voltage, so let's test this with the EV charger and see if it trips. So first up is the Tesla 50 amp charger. Now, it never shuts down the charger before you plug in the car. Also, this inverter can run other 240 volt loads no problem. I've run my heat pump and there was no issue at all. Now we're gonna plug it in. Okay, we're charging, guys. So right now we're charging with 22 amps and we'll see if it trips. Typically it takes about 3 minutes or so. Okay, it hasn't tripped for a few minutes now, so I'm starting to get excited. I still don't know what would cause the GFCI to trip on the charger. It just really confuses me just how those work. It should be anything downstream. So having a different source causing it to trip or not trip is very strange. Yeah, it's running, guys. No issues. So we'll come back in like 20 minutes and see if it's still charging. We haven't had the GFCI trip, and so now we're gonna increase the current to 31 amps. Then we'll go look at the inverter and see how it's doing. We're pulling 7,700 watts. From the battery, we're pulling 8,200 watts. Now I'm wondering what is going on with this inverter. I don't know why it's tripping that GFCI, but it doesn't do it on here. This one works flawlessly. Another feature I forgot to mention on these inverters is that each hot leg by itself can handle 4,500 watts. So your loads do not have to be necessarily balanced, but you cannot exceed 8 kilovolt amps total. But one leg can handle 4,500 watts, which is pretty interesting. And right now we're actually exceeding the max output and it's still running it just fine. And the leakage current is 13 milliamps, so that's not the issue at all. So my hypothesis was totally wrong. I wonder what is going on with this one. Why is it tripping the GFCI? If you guys know, please let me know in the comments section below, because that is a head scratcher. It's funny that this one was packaged better than this one, but this one's the one that's actually running, so we got really unlucky with this one. Signature Solar did the exact same test and they're not having this issue, so we're actually gonna send this one back. We're all laughing because I always get the bad inverter or battery or something. I have the worst luck. I always get the ones that have the manufacturing defects. So yeah, we're gonna send this back and then Signature Solar will send out a new one. So it is nice that we have a working unit. Let's continue to test this. I'm gonna charge up my car to full and then we're gonna think of some new tests that we can run through this thing. Now for the next test, we're gonna take the AC input and connect it to the grid, and we're gonna test to see if the zero export function works. And what this does is it offsets the loads in your houses, but it doesn't backfeed the grid at all. It powers the loads in your houses, but nothing more. And these are current transformers. These sense how much current is going in and out, and it will compensate how much this will feed to offset the loads. The CTs that arrive with the Megarevo actually arrive damaged. The cover is missing, and there's actually quite a few parts that are broken. These pieces actually broke off, so this is unusable. Oh wow, they broke off on both of them. That's not good. But the Signature Solar ones arrived in perfect condition. Nothing is wrong at all. And I think it's because they crate shipped these. The other ones were just floating around in the box that got damaged. Now we're gonna connect this load center to the grid, and then we're also gonna connect it to the AC input of this inverter, and then we'll add the CTs onto the supply. That way we can add loads to this and offset the loads without backfeeding the grid. So this should be really fun. So Hot 1 and Hot 2 have their own individual CTs. So this is our test setup and it's very messy. But over here we have a 50-foot, 50-amp NEMA 1450 supplying the AC input. Now this 240-volt supply goes into the load center, and right when it does, we have the CTs connected. And then this load center is connected to the AC input of the 8K. And now we need a load. So this conductor goes over there to the load center so we can run the shop's heat pump without backfeeding the grid and through the AC input. So this should be really fun. And these CTs are directional, so you have to ensure that the arrow is facing towards the supply. We have a 30 amp breaker going to the AC input of the 8K and a 50 amp breaker going out to the load. Now to make this system work and to run our loads off of the grid and solar without backfeeding the grid, we need to change the anti-reverse setting. And it comes disabled, but we need to enable it. And it's under System Settings. Oh, it's enabled. That's strange. If you buy it from Signature Solar, it should come disabled. So yeah, I would recommend everybody actually check that setting to see what it's at, because you do not want to backfeed the grid on accident. So yeah, check that setting. And then we're gonna turn on the breakers. Then we're gonna turn on the inverter. Now we can't touch anything over here at all. It is high voltage. And then I'm gonna turn on the AC input. Oh, we have voltage. Everything seems to be working. Now we can add a load. And we should have power. There we go. And look at that, it's running the heat pump. Now we do not have enough solar power to actually run this load yet, so we're gonna wait until the sun comes up. Maybe we should connect a larger array. I could do that in a few minutes actually. Now we have a second array, so we have a total of 3,000 watts connected to this inverter. So we're gonna wait until the sun comes up all the way and they actually have sunshine, and then we should have current actually feeding these loads. Now this system is very similar to a SolarArc 12K, but it doesn't have the same software and it's harder to set up. And that's what makes it so much cheaper than the SolarArc. But the SolarArc 12K is $7,000. So for under $3,000, you get pretty much the same features. It's just harder to set up. When setting this up for grid tie or anything else, I would call up Signature Solar and see exactly what settings they recommend, because that's probably the hardest part of this whole system. Also, if you buy it from Megarevo, I don't know what their support's like, I've never even heard of this company before. They're selling all of the same stuff as everyone else, and there's lots of other distributors doing the same thing, but I would try to stick to a US-based distributor that can actually give you customer service and support, especially when the settings are difficult to understand. Oh! We've got 1,000 watts coming in, so let's see if we're actually doing anything. We have 0 amps coming in, so we're not doing anything right now. I do not want to mess with these settings all day long. There are so many settings, it's crazy. They should just pay someone to make new software. It's worth it considering how much these units cost. Just hire some people. In the manual, it seems so simple. You have the AC input, loads, CTs, and 240 volt grid. I don't know what I'm missing. So I studied the manual for like half an hour and I messed with the settings and I can't get it to work. So I'm gonna call up Signature Solar and see if they have any suggestions. For now, I switched it to off-grid only mode and I'm charging my car and running the heat pump with this inverter. As an off-grid inverter, it works great, but I don't think people are gonna spend that much money for this when they could buy a 6500EX or a 6548 instead. So I think people are mainly buying this for the grid interactive features and I need to get those to work. So for the rest of the day, I'm going to try to figure out what I'm doing wrong, but if you need an off-grid inverter, this is probably not for you. Stick with an LV6548 clone, such as a 6500EX or something like that instead. But if you need the grid interactive features, this is the cheapest way to do it. It's just the software is not that easy to use. So I'll try to get this work and I'll let you know what happens. So another day has gone by and I'm about to lose my mind. I have tried every setting that Signature Solar has recommended. I know this is not their unit, but their unit was also defective and that took multiple days of me trying to figure out. And yeah, this is not a fun experience. This should be a very easy to enable setting and feature, but the software on these units compared to what they are a clone of, a Solarc, is very difficult to use. The whole reason people are buying this is so that you can have grid interactive features similar to the Solarc for a cheaper price. Also, I think Signature Solar and other companies are still trying to figure out how to use this thing. Now, usually I don't like to listen to any of these distributors because even though they sell the same product and they have the same exact manual, I like to learn it on my own and not listen to them. But even with their help in trying to read the manual every single day for about a week now, I still cannot figure out how to use this thing. And I recommend everybody watching this to download the manual and see what I'm talking about. Look at each setting and how it describes it. It's very, very confusing. And this feature I'm trying to make work is very simple. You have 2 CTs, you should just be able to enable it and it should just fire right up and start working. But nothing I have done has been able to solve this and make it work at all. And it's manufactured by a very good manufacturer that makes all the other more expensive inverters, so there's no reason that this can't do it, but I simply can't because this software is very hard to use. Maybe in the future they'll have an updated firmware that makes it easier to program. That would be very nice. Now, Signature Solar says they're going to get it to work and they're going to change the manual and make it easier to use. So we'll come back to this inverter at a later date because I really want to have an inverter with these features at this price. But I can't get these ones to work at all. And the first one was completely defective because it was tripping the GFCI every single time. And I still haven't figured out why. So this thing is confusing the heck out of me. Usually I can figure this stuff out in less than an hour. But this has been like a week of headache. Also, it threw off my video schedule. We have another inverter up here that I want to test, and we have to unprofessionally have this one on the ground upside down because that one is ridiculously heavy and I'm not going to take it off until I'm done with that video. So it's very unfortunate that these do not work or they're defective and the software is hard to use, but we will come back to these at a later date. I really wish the software and the manual was ready to go for my video so I can just throw it on the stand, do some fun testing, and then move on to the next video. But for this one, it's not proving to be very easy. So I'm going to take apart this system and move on to the next videos. Once they have a new manual and they know what settings to change to make it have the features that we need, I will rebuild the system and we will test it from there on out. But for now, I'm pretty disappointed in this inverter. So thank you so much for watching and I will see you in the next video. Bye.